Hey, we are back with the problem of the day, and today we have Kadane's algorithm. Let's read the problem statement. The problem statement here says, given an integer array ARR, find the contiguous subarray containing at least one number that has the maximum sum and return its sum. Okay, what do we mean? Well, here are a few sample test cases which will let this question be understood with more clarity. Let's take up this example. So you have this array ARR. Now you already know what subarrays are, right? So any part and like any continuous part of the array is called as subarray. Here, let's consider 1 and 2. Let's consider this subarray. So what will be the sum of this? The sum of this will be 3, right? Let's consider one more subarray. I've considered 1, 2, 3 now. Then the sum would become 5 and 6 here, right? Okay, now let me take this array. What would be the sum? It would be 5, 5, 10 and negative 2. It would be 8, correct? So you can see here, in this array, we can make multiple subarrays and we can have sum of all these subarrays. Now, what the question is asking? The question is asking us to find out such subarray in which we can have the maximum sum. So far we have seen that I have, like with the few examples that I've chosen in front of you, I have these three numbers. So out of these three, 8 is the maximum. But is 8 the maximum for all the combinations possible? Well, it is not. You can see here, if we take all the elements, correct? If we take all the elements, then the answer would be 9. Okay? And this is the maximum sum possible. But is it going to be the case with every array? No, of course not. Why? Because in this scenario, this negative number was impacting, but not that much. Okay? More examples you're going to see, we will explore that how this negative number is actually bringing down our sum. Because if there is no presence of negative number in an array, then for sure the maximum sum is going to be taking the complete array. But because these negative numbers are introduced, we need to be a little more careful while choosing our array, the subarrays. Okay, you can just see this condition, right? No negative number is there. And you have chosen this. That means all the numbers are chosen. In this, all the numbers are negative. Thus, we are going to take this negative 1, being the biggest number out of all. Okay, because in this negative 1 is the maximum subarray sum. Okay, now I hope you have started understanding the question. Let's try to consider its approach. One brute force way of doing this question is going to be choosing all the possibilities and then choosing the maximum out of those. So for finding out all the subarrays, let me take an example for you. Let's say we have 4 elements in our array. So what are going to be like the total number of subarrays possible? Right? Let's say I have to make subarray of 4 elements. Then it is going to be of 4 length, right? And only one subarray is possible. Let's talk about what about 3? Okay, if we find subarrays of length 3, I can make A, B, C, and I can have B, C, and D. Similarly, let's say if I ask you how many subarrays of length 2 are possible, you can tell me that AB is possible, BC is possible, and CD is possible. For 1, we have A, B, C, and D. Okay. So for 4, 1 is possible. For 3, 2 are possible. For 2, 3 are possible. And for 1, 4 are possible. Can you see the sequence here? Okay. If I have to ask you what is the total number of subarrays here? Okay. It is going to be 4, 5, 6, 7, 8, 9, 10. The total of all these. Okay. I gave you example for an array of length 4. Let's say I have array of length n, then this is nothing but sum of n natural numbers. Okay, so for that we know this is going to be our solution, right? And it is going to go up to n square, correct, the exponent, and in the manner that we are going to find it out is going to be a nested looping, right? So for that, if we are finding out all the subsets, it is going to be a n square solution. And then we have to calculate the summation of all, which we can do parallelly. And eventually, the complexity is going to land up at n square. Does this approach ensure our answer? Yes, it does. But is it optimized? Well, we have to work on that. It is not optimized yet. The question here asks us to solve this question in order of n. Okay? And that is done by one algorithm, one very famous algorithm called as Kadane's algorithm. Okay? I have taken this example here. I'm going to just try to run the algorithm in this example so that you can understand it better. Okay? Fine. So what do we do in Kadane's algorithm? First of all, we perform only one iteration. So we are only going to go in this direction once. Okay. Along with the traversal, we have to maintain a few variables. Okay. Let's say I am maintaining one variable called as maximum, or let me call it maximum answer. This is going to be the variable which will be storing my final answer. What do I have to find? I have to find the maximum subarray sum. Eventually, I'd be having my answer in this variable. For help, I'm going to be having one more variable here, and I would call it sum so far. So let me just write it SSF for short. Sum so far. Initially, both of these are going to be, let's say I'm marking my maximum answer with the first element, so it is 1, and I'm marking SSF sum so far as 0, considering that I am just beginning up the iteration. So in the first iteration, let's say I am including 1, then the maximum answer so far. First of all, let's calculate SSF, the sum so far. The sum so far is going to be 0 plus 1. It will be 1, right? The maximum answer. What is the maximum answer so far? 1, right? So it is going to be 1. Let us move ahead. One more iteration. For this one, my SSF is going to be 1 plus 2. It will change to 2. Now I have to compare that the existing maximum answer that I know is 1, and the new sum that is being generated is 3, correct? So MA, or maximum answer, keeps the track of the maximum values that we are encountering. Okay, so here I'll update this. Let's go for one more iteration in which 3 is included. SSF will go for 3 plus 3, 6. Sum so far has become 6. The maximum answer would also change to 6 due to obvious reasons. Now including one more value, SSF now will, at this point it will become 1 because we are including -5 here, right? Now do we need to update our maximum answer? No, it will still be 6 because we have found one array so far which is having 6 as the value, and till this point 6 is the maximum that we have encountered. Let's include one more value here. We encounter -1. So SSF, it's changed to 0, right? Maximum answer so far, it got to, it is still a 6. Or let me just try to show you one thing more. From instead of -1, let me write -2 here. So in this case, my SSF would become -1, and my maximum answer has become 6. We have not updated it. At this point, it is 6. Now you need to make a clear observation here. We are forming our possible answers with SSF, sum so far, and we are keeping the track of maximum with maximum answer. At this point, my SSF, or sum so far, is becoming negative. So think yourself, would it contribute to my answer at all? If I include, so far, if I am including this array till here, eventually it is becoming -1, which is less than 0. Something which is less than 0, it is not going to be contributing to my answer ahead also, right? So at this point, whenever the value of my sum so far gets negative, I would explicitly change it to 0, okay, in the same iteration. Fine. Let's move ahead in the next iteration. For this one, my SSF has become 0 now. I will include 3, it will become 3. Fine. Maximum answer so far, it still is 6. Now after taking 4, what will change here? 4 plus 3, that will become 7. That means SSF, this is the new iteration, SSF has become 7. My maximum answer so far, my maximum answer would change to 7 now because I am encountering a bigger value than 6. Then I have to include the next element, which is -1. So here my SSF would become 6 and my maximum answer so far would be 7, right? After this, the iteration ends And as I said to you, as I told you before, that maximum answer would be containing our answer. Yes, eventually it is containing our answer 7, which is correct. Okay, and in that we have taken this subarray. We could not have taken this subarray. This sums to 6. We could not have taken this subarray because it is also summing to 6 because -1 is included. We can just take 3 and 4, which would sum up to 7, and 7 would be the maximum for this example. Okay, so now it is clear. What are we doing? We are maintaining 2 variables. We are performing 1 iteration. And what are those 2 variables doing? Sum so far is creating possible answers, and maximum answer is keeping the track of maximum. Fine. Let's quickly see the code for the same. Okay, so here is the code. You can see I have declared 2 variables. This one is answer, or you can say maximum answer, same thing. I have put the first value of my array here so that the cases in which only negatives are there, that is also included. Then I've taken sum so far and I've initialized it with 0. I'm performing my 1 single iteration here. Here, what am I doing? I'm calculating sum so far. Sum so far is just including the next element in itself. Fine. Then I'm keeping the track of maximum answer like this. Whatsoever is the bigger value of the answer and the sum so far calculated, I'm going to keep the maximum of those two, right? And here I'm performing a check that at any point, if my sum so far is going negative or it is becoming 0, I'll just change it to 0. I don't want my negative value to be carried ahead so that, it would be affecting my other subarrays. I don't want that. Eventually, when this loop has run successfully, as we have seen before, we will return the answer. So I hope you've understood this, and the complexity that it will take is going to be order of n, because we are just performing 1 single iteration and we are not using any extra space. So the space complexity is going to be order of 1. Clear? Let's just pass this code to all the test cases. All right, so here's the question and the test cases. Let's try to compile it. All right, you can see it is passing for the first sample test case. Let's submit that and pass it against all the test cases. It has passed all the test cases. So Kadane algorithm is one of the most basic and crucial algorithms for arrays. So make sure you understand it properly. And if you found it difficult anywhere, try rewatching the video. And if you don't if you have any question, you can put that in the comment section. I'll try to answer that. And if you liked the solution, if you liked the approach, please just give the like.